Welcome back to Geometry Chapter 11, Section 1 in this book. And we're going to be talking about angle measures and polygons. So for the rest of the book, we're going to be talking a lot about polygons, about different figures and shapes. But really what you think of more is classic geometry, figuring out areas and volumes and things like that. So first of all, we need to be able to name our polygons. So, you learn how to count in Spanish, uno, dos, tres. You learn how to count with different situations, like in chemistry, you have to count the number of carbons in organic. Well, for our shapes, you need to know how to name them. So if a poly means many, gon means side, you can kind of think of it. And so a triangle is named on its angles, but 3 is tri. But then you have a quadrilateral, means it has 4 sides, quad meaning 4. But then we go to gons. So 5 is pent. We know that one. The pentagon, we've heard of this. Pentagram, we've heard of that. Hex, we're pretty familiar with too. Hex, so it's pent, hex. But the one nobody seems to know is 7. It's hept. Hept. And then 8 is oct. We're pretty good with that one because how many legs do an octopus got? 8 legs. 8 legs. It's a song by Flippy the Fish Head. Look it up. Okay. 9 is non, and that makes sense because 9 and non both start with an N. And 10 is deck. And we kind of know that one. I already went on my spiel about it's like des. And when people say that something was decimated, they use it wrong because it's only 1/10 was messed up, not the whole thing. So if your troops are decimated, it was not that bad. 90% lived, 10% died. All right, polygon interior angles theorem. It's that if you have a polygon, remember how we learned that the 3 angles of a triangle add up to 180. And the 4 angles of a quadrilateral add up to 360. Well, you can figure out what any polygon's interior angles add up to with this formula. It's the number of sides minus 2 times 180. And that's the sum of the interior angles, the ones on the inside, like that. Okay? 3 dots mean therefore. That's a nice little abbreviation. Therefore, since all of them is the number of sides minus 2 times 180, to get one side, you would do this, then divide by how many sides you have. So therefore, each angle is the number of sides minus 2 times 180 divided by the number of sides equals each angle of a regular n-gon. Now, if it's not regular, if all the angles aren't the same, that won't work. It would tell you only what it is if they're all the same. Remember, regular means all the same. All right, now there's another theorem we're going to learn too. The sum of the measures of the exterior angles, the ones on the outside, if you continue the lines, of any convex polygon is 360. And so the exterior is 360, the interior you have to figure out. Don't get those mixed up. Okay, interior you figure out, exterior 360 no matter what. All right, so here's one where we know all of the interior angles but 1. So step 1 is we count the sides. 1, 2, 3, 4, 5, 6. So we know n stands for number, is 6. So the n minus 2 times 180 will tell you the sum of the interior angles, what these all add up to be. And so that's 4 times 180, which is 720. Now we can put it in our formula that to be able to get our missing one, just that all of these added together is 720. So we add them all together plus our x, and we get 607 plus x. Then y is x not alone, it's got a 607 added to it. So you subtract both sides by 607 and you get 113 equals x. Alright, so this time we have a regular polygon where each angle equals 140. How many sides does it have? Well, we can use this formula that we could say that we don't know the number of sides, but we know that each one is 140. and we know the 2 and the 180, and we can solve for n. But before we can say why is n not alone, I'm going to say why is it ugly, and it's because it's a fraction with an n in the denominator. So I'm going to get rid of that first by multiplying both sides by n. Those cancel out, and I'm left with 140n equals 180n, because I have to use the distributive property. 180 times n is 180n, and 2 times 180, negative 2 is negative 360. Now I can gather up my terms by subtracting 180 from both sides, getting all the n's on one side. Those cancel out, and then 140 minus 180 is 40n, and I still have a negative 360 on this side. Why is n not alone? It's being multiplied by negative 40. Divide both sides by negative 40, and n equals 9. So this was a nonagon. All right. So now here's one with the exterior angles. Remember how you do an exterior angle is you extend the line, and you can extend both lines, but you only pick one side to be the exterior angles. It really divides it into 3 sections if you extend all the lines. Do you see that? Section, section, section. But you just pick one of them. So I picked the one that is on this side going around. Whoop, whoop, whoop. Okay. And I know that if I add them all up, that it's 360. So I've just wrote them all down. X plus 2x plus 2x plus 4x plus 3x equals 360. That's 12x equals 360. Why is x not alone? It's being multiplied by 12. Divide both sides by 12. Those cancel out. 360 divided by 12 is 30. All right, here's another one. And we want to know what x is. To be able to find out what x is, we can use this, that one regular exterior angle is 360 divided by n. So we count our sides to find out what n is, and there's 7. So we want to know what one of these little exterior angles is 360 divided by 7. It's 51.4. All right, so those aren't bad. It's just a couple of formulas. By this stage in your math life, you should be able to use a formula. So hopefully it's not too terrible. Come back next time and we'll talk about areas of regular polygons. Ooh, math is great.